Oh, hi there. Thanks so much for showing up for your math learning. It's Tutor Grant. And today we are looking at the last question of the Cayley 2021. It's a tricky one. And there's, of course, 3 steps to problem solving. The first step is figuring out what this problem is all about. So don't worry, I'll walk you through that. The next step is choosing a strategy. I've got to say, I've solved this problem a number of different ways, and they keep getting simpler. So I want to thank my students, for particularly Arvind and Ethan, for showing me some really simple ideas that are hiding in plain sight, as it were, that give us some shortcuts. So I'll show you the best shortcut version today, but we will use a little bit the equations of lines. So yes, all right, so let's go. First, we start with these 2 points, J and K, and I've plotted them here. Here's J, and here's K. And we're told to make a third point to make a triangle. The other point is at points R and T, where R and T are between 0 and 10, okay, in the X and in the Y. So that gives us what we are working with. All right, so we can choose any other point in this 10 by 10 grid to make our triangle. But we want our triangles to have area equal to or less than 10. So let's just choose one at random. Boop. Okay, there, I chose that one at random. You saw it. All right, so this one looks like this. And then we find the area of that triangle, and oh no, it's more than 10. Okay, so that's like the idea. So we want to find this region R, inside of which any point you choose gives you a triangle that's area less than 10. Okay, so there's some region in here. Maybe it doesn't look like this, but maybe it looks like that. And this is R, and any point I choose in there would give you a triangle that's 10 or less. And we want to find R's area. Okay, that's what this question is asking us to do. All right, so now we know what we are looking for, this region R. And now let's think about some of the things that we can use to find this. All right, I know that the area of a triangle is equal to base times height divided by 2. So if I only knew something about this triangle's base and height, I could start picking some points. I for sure know this could be one of the lines in my triangle. And hey, would you look at this? It happens to be 4 high and 3 wide. And I don't know the last time you saw a triangle with legs 3 and 4, but then you know that this is 5. Whoa, that makes it easy, doesn't it? That makes it easier to find some triangles that have a base of 5 and a height of 4. So I already have one of the sides as 5. So now you might be thinking, well, all I need to do is be perpendicular and go out 4 that way, and that should be within R, right? And that's true. That's good thinking. Okay, and you could also go out this way, and that could be 4, and that could be perpendicular, and that would also be like the edge of R. Oh, great. Okay, we're starting to see it now. All right, there's some line of points that goes through here where it's exactly 4 away from that line that we have over there, and that is the upper edge of R. All right, but what about the lower edge of R? Well, we would just have to be 4 away this way. Gee, I wonder where that would take us. Okay, so if we're 4 away that way, we would still be making a triangle. All right, that would be within 5. And of course, we could go 4 over here, but that puts us outside. But that idea is still useful. There's some other line that goes like that, within which, okay, inside of those 2 lines is the region R. And it's parallel with this, and the edges are parallel with that line, that first line that we drew, between the points J and K, 2, 7, and 5, 3. Okay, so that's your region R. That's what it looks like. Now we just need to find out how we're going to find this thing's area. I mean, what is its shape, and where are some of these points? My goodness, it's very tricky, isn't it? Still very tricky because we still have a lot to do. But I'm going to just highlight basically what we're looking at. It's like some kind of hexagon that looks like this. Okay, it's some kind of hexagon-y thing that looks like that. But we need to know its area. Gosh, area of a hexagon was already, there's still a lot of work. All right, but some of you might be saying, well, I see a shortcut already. If we could find the area of this little triangle here and the area of this fair bit bigger triangle there, then the area of region R would be equal to the area of the square minus area 1 minus area 2, and you'd be right. Okay, and the area of the square is easy to find. It's 100. But now we need to find A1 and A2. And don't you know it, we need some points in there. Now is where I'm going to say thank you to Ethan and Arvind, because I just like found the gradient of this line. We're going to need this in just a second, okay? This is gradient, so the gradient here is -4 on 3. I found the equation of that line. I went out from this one, perpendicular, so that's the gradient m is equal to 3 on 4. So here's an idea for you that's alive in this problem. The gradient of a perpendicular line is the negative reciprocal of the other one's gradient. So those of you who have studied these types of things, you'll see an application of that here. All right, and so we're using these ideas, but I still need like 1 point on those lines. Okay, they'll also have gradient -4/3. And thanks to Ethan and Arvind, who showed me that if you go this way, well, that's 5 there, isn't it? And this is 4 high, so that is one of our points. That triangle has area 10, so this point is exactly on the edge of R, this region, and the line that's parallel to this line runs through that point. So that's the point 0, 3. So let's find the equation of this line here. I'm going to call it y1, and then I can use that to find this point down here. Oh, what about a point on this line over here? Well, you can go 5 this way, hit this point, okay, and then make your triangle like that. Ew, gross triangle. But then it still has a height 4. Okay, the top of the triangle doesn't need to be over the base. We can go way like slantwise and still have the same area. So that's super useful too. That is the point. 10, 3. So we're going to find the equations of these two lines, and so you're going to get to see how that applies. And then with that equation, I can find this point and this point. I need those to find the areas of A1 and A2. So we're going to call this like Y2, this line. So Y1 equals mx plus b. All lines have the form mx plus b. But then, well, with some notable exceptions. And then we have Y1 is equal to, we know the slope. It's a -4 on 3. We know the gradient, because it's parallel to this line that has the gradient -4 plus 3, okay? This one goes down 4 in the y and over 3 in the x. Great. And then we're going to calculate the b, and we can use this point here. So when x is 0, y1 equals, when x is 0, y1 equals 3. So we have 3 is equal to -4/3 times 0 plus 3. Yes, the b value is always the value of the y-intercept, so super useful. Okay, so that one is saying that this equation is y1 is equal to -4/3 x plus 3. And now what we want to do is find the x value here where y is exactly 0, because that's the other edge limit of R. So let's go. Okay, we're going to set y1 equal to 0 is equal to -4/3 of x plus 3. Swing that 4/3 x over to the other side of the equation. You get 4/3 x equals 3. And then multiply both sides by 3/4, and you get x is equal to 9/4. Okay, just multiply here by 3/4. Multiply here by 3/4. And the 4's cancel. And the 3's cancel, and x is equal to 9/4. So I have this one is 9 on 4, and this is 3. Okay, so I can use that for area 1. So this is my area of R is equal to 100 minus 3 times 9/4 over 2. Okay, so that's the area of the triangle A1. Now let's work on A2, which is defined by Y2. Okay, so Y2 also has this equation, minus 4/3 is the gradient, x plus b. But the b value is going to be much greater, okay? I'm expecting the b value to be like, you know, up there maybe in and around 15, 16, 17, something like that. This is going to be big. Okay, I'm going to use this point to find out what it is. So when y is equal to 3, the x value is equal to 10. So we have 10 there. Let's just sub them in for x and y. And then we swing this over to the other side. So this is 9 on 3 is the nicer way of writing 3 in this context. Plus 40 on 3 equals b, because I add 40 on 3 to both sides. Okay, so that's how we find out that b is 49 on 3. So 49 on 3 is actually like, what did I say? It was 16 or 17? Yeah, 16.3 recurring. Okay, so 49 on 3 is b. Now, we want to know when y is 10, what's the value of x? Because that's going to give us the length here. We know this one is 7. Okay? There's an easier way to do what I'm doing. I just really wanted to show you lines. I promised you the simplest solution, and I'm not doing that. I wanted to show you how to use the equations, the lines here. Okay, so I'll explain the easier way at the end. All right, so so now we're just going to say, well, we know that this has equation, well, y2 is equal to minus 4/3 x plus 49 on 3, and we want to know when is y2 10. Sorry, yeah, for what value of x is that true? All right, so then we subtract 49 on 3 from both sides and get minus 9 on 3 equals 4/3 x, which is to say, wait, what? Oh, minus 4/3 x, right, which is to say 9 equals 4x, because we're going to multiply both sides by minus 3, and x equals 9 on 4. Isn't that interesting? Okay, these 2 points, what? Supposed to be right on top of one another. 9 on 4. Did I have an error? I definitely don't want to have an error here. That doesn't look right to me. Okay, so we're going to subtract 9 on 3. Oh no, that's not minus 9, it's minus 19. Yes, I knew that was wrong. I did a weird thing up there. Okay, bear with me for a second. I was skipping steps and was talking out loud. So what I do is I subtract 49 on 3 from both sides. And I know that this is the same thing as 40. So no, 30, that's the mistake I made for some reason. I was working with a denominator 4 in my head. 30 on 3. Okay, so I get minus 19 on 3 equals that. And then so x equals 19 on 4. We just need to do that. Okay, there we go. Now, one thing I'll point out here is I made a silly calculation error while I was doing that, but because I'm working with a visualization, I am like, that's not right. I need to go back and find my error. So anyway, now we have the ability to find this distance here, which is going to be 10 minus 19 on 4, because this is the point 19 on 4, 10. Okay, that's at the x point 19 on 4. So to find this distance, we just take it away from 10. And that's the distance here. And 10 minus 19 on 4 gives us 21 on 4. That's the distance there. So now we have all that we need to calculate A2. So A2 has a, we'll call it a base of 21 on 4 times a height of 7 divided all by 2. Okay, because it's a triangle. Now we have everything we need to work this out. So we have 100 minus 27 on 8 minus, that's, what is that? That's 147. Minus 147 also on 8. Okay, And 27 on 8 minus 147 on 8 is minus 174. 100 minus 174 on 8, which again is a fancy way of saying 100 minus, that's 90, 87. 87 on 4? Indeed, 87 on 4. Well, we can write that a little differently, can't we? 100 is the same thing as 400 over 4 minus 87. And then we get our final answer. 313 over 4 is the area of R. Nice. All right, so what do we do with that? How do we input an answer like 313 on 4? Well, take a look at how they want us to enter it. They told us it could be written this way. So if 300 plus A over 40 minus B equals this, then that means A is equal to 13 and B is equal to 36, and A plus B equals 49. That's the correct answer. All right. So I promised you a simpler way of doing it. So let's take a look. The simpler way is you notice this point. You notice this point. You know that this is a 3, 4, 5 triangle. Okay, so we have that earlier, all right? That's a 4, that's a 3. And this is going to be parallel. And this is going to be parallel. Something like that, all right? And we're going to find the area of this triangle. And we're going to find the area of that triangle. And we know this is 7. And we know this is 3. But this is just a scaled down 3, 4, 5 triangle, because it's parallel with this line. So we have, like, let's say we don't know this side, so we'll call this x1. And so then we have x1 on 3 is equal to 3 on 4. So x1 equals 9 on 4. Okay, this one here, same thing, all right? But in this case, we have like this, call this x2, okay? In this case, we're bigger, all right? So we're bigger than a 3, 4, 5 triangle, but we're the exact same shape because we're parallel, all right? So this one over here is, how do I set this up? Oh, right, x2, sorry, on 3 is equal to 7 on 4. So then we multiply that through, and x2 equals 21 on 4, and that looks really familiar, doesn't it? And that's a lot easier than using the equations of lines, isn't it? Ha! Amazing. Okay, so I hope you enjoyed both methods. The easy method, well, it's not easy. It took me a week to develop a nice smooth method like that, and I needed help from my exceptionally bright students. So, and I'll also point out I have some very bright students who do it exactly the same way I did, doing all of the work, and they do it beautifully and get the correct answer. So there's lots of different pathways to the top of the mountain, but the clarity you get from standing on the top of the mountain is always the same. Okay, so I hope that was lovely for you. It was lovely for me. Thanks so much for showing up for your math learning. Bye!